Hey everyone, Geophysicist Stefan Burns here. We have just had 3 separate asteroids hurtle past our planet closer than the Earth-Moon separation distance just in the past few days. This is pretty anomalous. To have one asteroid do this every now and then, yeah, it happens. To have 3 in less than a week, that's a bit bizarre. Thankfully, none of them hit the Earth. And thankfully also these asteroids aren't the biggest. We have J01 passing at 0.3 lunar distances on the 7th. You have J0 passing also 0.3 lunar distances on the 9th. And then you have JD1 there passing 0.8 lunar distances on the 11th. The sizes for that would be 6, 9, and 12 meters respectively. So Tunguska, for reference, was the largest known asteroid impact in recorded history. That was June 30th, 1908. That was with a diameter of about 40 meters. Exploded in the air, creating air bursts, but flattened trees all around. If you want to look up this asteroid data, there's a variety of resources. I'll link them in the video description, but just to start off, I really do find on spaceweather.com, their section lower down, very useful, the near Earth asteroid section here. And so you have to keep in mind that we don't discover a lot of these asteroids until they do their close flyby. That's one of the big drawbacks right now. The fact that they get so close allows us to detect them, because an asteroid 6 meters across, 1.5 astronomical units away from the Earth-Sun separation distance being 1 AU, you're not going to see the thing. But if it gets within 0.3 lunar distances, we'll pick it up. So these were probably added after they did their flyby, but we see them all here having this dark orange coloration indicating that they pass closer to the Earth than that lunar separation distance. So you can always go to this webpage to see this yourself. And just to kind of play around a little bit, here we can see what an asteroid impact would look like. So if we go to a diameter of the biggest one that we have, which is about 40 feet, it's 12 meters, so about 40 feet. And the speed on that one, this is JD1, that was 31,800 miles per hour. So we'll type in, we'll get 32,000 miles per hour right here. I'm just putting in the different things. We'll keep the impact angle 45 degrees, okay? And we're just gonna drop this over New York here. Sorry guys, but let's see what happens here. The asteroid blew up 11 miles above the ground. The explosion was equivalent to 87 kilotons of TNT, and an impact this size occurs about every 17 years. You notice there's no damage from this. So it would have been certainly a huge sonic boom. People would have been freaked out, giant fireball coming down, but it probably wouldn't have actually impacted in any significant way. But Tunguska, for reference, has a diameter of about 130 feet. So we'll keep it at 100 here because I can't put in 130, but we'll keep it at 100, and we'll keep the speed about the same. Again, we'll drop it over New York again, and let's see what happens here with this impact. And this is smaller than Tunguska, okay? Explosion equivalent to 5 megatons of TNT. Impact this size occurs once every 390 years or so. Blew up 2.1 miles over the ground. 197 decibel shock wave. Hearing issues, building collapses. This is a big deal, as you can see. Peak wind speed, 548 miles per hour. So, and it's saying here, oh my God, an estimated 300,000 people would die from the wind blast. So even just an asteroid 100 feet in diameter can be catastrophic if it hits the right location. And well, we have a lot of asteroids in our Earth environment. So here we see a visualization. This is showing not only the main asteroid belt, which goes from 2.1 to 3.5 astronomical units. There are thousands of objects greater than 40 kilometers in diameter. You don't want one of those hitting Earth. But we also have tons of near-Earth asteroids, which is these 3 asteroids. They're in that body, so they get close to Earth. So they're a near-Earth asteroid. And we are finding more and more of these all the time. Every single day we are discovering more of them. There are a ton out there that we don't even know of, and hopefully we don't discover them too late, posthumously after an impact. Tunguska 1908 was a big deal. Thankfully, it hit Siberia. It flattened about 2,150 square kilometers of forest land, and that was 830 square miles for imperial units. So huge, huge, huge blast from that. And thankfully, I mean, there were some people killed, some local natives and Inuit, I guess. That's some of the reports, but basically didn't, really no one saw it for the most part. But over a populated city, it's a big deal. So these sort of impacts are possible, and to get 3 in just under a week with these close flybys is quite significant. And you're going to get that just statistically. There's going to sometimes be these asteroid convergences and they don't impact, but you hope that continues to not result in impacts. And instead, you could get sometimes the hit to occur. That can happen at any moment in time. We hope that's not the case, but we are seeing something unusual right now in our near-Earth environment because, as many of you know, in March, we had a huge surge in big fireballs. So for the American Meteor Society, March 2026 was the top month for fireball sightings. These are big fireballs that are having sonic booms and recoverable fragments from the ground, hitting houses in Texas and in Germany. And there was also a fireball that flew over Ohio. They recovered fragments from that. So April was also quite significant, though not as much as March. March was the key month. And then things started to die down near the end of April. So it's really like March to the middle of April that we had these big fireball events. And now you see in May, even though I'm filming this now, May 11th, we've only had one event with more than 100 reports. So it has been quite wild for March and April. We don't exactly know why we had so many fireballs. Most of them came in from the Anthelian source, which is opposite of the sun. So that's interesting, but there's a lot more questions here than answers. And now just in the past week, we've had 3 different asteroids fly in closer than the Earth-Moon separation distance back to back to back, with each one getting bigger. 6 meters in diameter for the first one, 9 meters in diameter for the second one, 12 meters in diameter for the third one. That's 40 feet across. Tunguska, again, was about 130 feet across. So there's the surface area to volume ratio, and what's it made out of influences how it's going to interact with the atmosphere and explode. If you have a more siliceous meteorite, silicon base, it's going to be quite a bit different than an iron meteorite. But regardless, as they get bigger, the destructive potential increases. And I really just see this as a reminder that our planetary environment is much more dynamic than most people realize, and we still don't fully have it mapped. We actually don't have that many probes in space at the end of the day. We have like different space weather monitoring probes and different probes orbiting around, for example, like Mars and Jupiter and stuff. But at the end of the day, we really don't have that much out there. We have some really amazing all-sky telescopes now that do exist, but they're really looking not so much for like asteroids. I mean, there are some, but this is a big uncertainty effectively that is looming over us at all times. And it's not something to be freaked out about all the time, but it's good to be aware of these dynamics because Earth was created through accretion of these sort of asteroids and meteorites, and we call them planetesimals. That is how the Earth formed, and that is how the Earth will continue to evolve as these do continue to rain down over geologic time, influencing the development and evolution of our planet. So that is your asteroid update for today. I've been your host, Stefan Burns, geologist, geophysicist, space weather guy. Please subscribe to stay up to date on everything that's happening here on Earth with our sun and our space environment and more. We have a big sunspot right now that is rotating towards Earth direct, that's been blasting off huge solar flares and coronal mass ejections. We just had a mega sunspot form on the sun, now rotating to the far side. So we do have an increased risk of a radiation storm if that explodes. In the days ahead, we have a superior conjunction of Mercury coming up on the 14th to the 15th. We have a new moon on the 16th. We have a very large coronal hole that will be Earth center and geoeffective right in these time periods of mid-May. So we have a critical energy convergence for the middle of May, which we are rapidly approaching, and I'll keep you updated on all of that. So thank you all so much. Have a great day, and I'll see you all in the next video.